Good. The same idea. We will square both sides. The left-hand side is easy. Can anyone give us the left-hand side?
24 minus 2x.
Of course. Can anyone give us the right-hand side?
X squared.
That's it. I move everything to one side. X squared plus 2x minus 24 equals 0. I always hope it's factorable. And this time it is. Anyone, please?
X plus 6, x minus 4.
Excellent. So I have x equals negative 6 and x equals 4. Is it? I don't know. I have no idea. So I will go back to the original problem. Here's the original problem. 24 minus 2x equals x. I will replace first by negative 6. Of course not. The left-hand side is a positive number because it's just the radical. It's nothing else, just the radical, and that is positive, and the right-hand side cannot be negative. Now I will check 4. Negative 2 times, I'm sorry, yes, negative 2 times 4 is negative 8. 24 minus 8 is 16. The square root of 16 is 4, and I will say yes. So again, this solution that does not work in the original problem is called extraneous solution. Extraneous solution. Coming from this, but not from the original problem. And it has to be excluded. Extraneous solution has to be excluded. It's a byproduct, if you want. Residual, something that is not acceptable for this problem. Did we get the idea? Is there any other problem that you would like us to work on? It can be from your own assignment. Should we work on this one?
I do have a question about the equation of appropriate substitution. It's 4 to the 4th power. It's x to the 4th power minus 257 x squared plus 256 equals 0.
So we haven't gotten to this because this is a polynomial equation.
Oh, okay.
So we're going to work on this in a minute.
Okay.
I promise, when we look at the radicals. So let's finish the radicals and see if anyone else would like to work on another problem, and then we'll look at polynomials.
This one, please.
Okay, perfect. So we want to look at this. So this is the square root of 2x plus 5 minus 1 equals x. Perfect. Remember to clean it up. The radical has to be by itself on one side. By itself. So what should I do to both sides to clean it up, as I like to say?
Square them both.
Not yet.
Add 1 to both sides.
Yes, I have to do that first. You have to isolate the radical first. Isolate the radical. Always make it easy. So now when I square the left-hand side, anyone?
2x plus half.
Excellent. The right-hand side, careful, please. The right-hand side. Can anyone give us the right-hand side?
Squared plus 2x plus 1.
Excellent. X squared plus 2x plus 1. Luckily, I love it. I move 1 to the other side. Can anyone give us the solutions? They have to be 2. And remember, the easiest is to take the square root. But you have to give me 2 solutions. Can anyone give two solutions?
-2 and 2.
Very good. Plus or minus 2. A big, big question mark. Big question mark. I have no clue if they work or not. I have to check before doing anything else. So here's how I do it. I copy the problem. If I put here -2, I cannot draw conclusions immediately because I have a -1, who knows, whatever. So I'm going to check. 2 times -2 is -4, plus 5 is 1. The square root of 1 is 1, but 1 minus 1 does not equal -2. So now I'm checking x equals 2. Okay. Checking x equals 2. 2 and 2. 2 times 2 is 4. 4 plus 5 is 9. The square root of 9 is 3. 3 minus 1 is 2. Yes. And I will say yes. Mandatory to check. Mandatory to isolate the radical first. Careful how you square. It will always change into something else. Quadratic. Solve the quadratic. Check solutions. Plus or minus work here. Plus or minus 2 are correct here, but not correct in the original problem. Did we get the idea about radicals, radical equations? What would you do first here? How will you clean this up first? You would?
Would we take away 7 on both sides?
Yes, that's the first step, and then you square, and it's simple from there. Okay. So since Lali brought up the polynomial, let's look at polynomial equations. And then I'll come back to the rational exponents that we have here. I just want to see what else is quickly. They're all like that. Okay, perfect. So now I'll come back to this assignment, but I want to jump to part 2 so we can answer Lali's question. So somehow she got directly to 9.2. I mean the second part. Okay, so we're going to start with her equation. It's the same with this one, identical. So let me copy it again here. So she gave us x to the 4th minus 257x squared plus 256 equals 0. Okay, perfect. So as you see, this is a polynomial. What is the degree of this polynomial? So remember, degree 4, excellent. So degree 4. How many solutions do we expect? Real, imaginary, no matter what. How many solutions we expect? So when the degree was 2, how many solutions did we get?
2.
Yes. When the degree is 4, how many solutions do I have to get?
4.
Exactly. So the exact degree. Perfect. They may be all real, they may be real and imaginary, they may all be imaginary. Who knows? But I expect 4 solutions. Now, this polynomial is something called quadratic in form. And you can say, what on earth is this? And how do you know? Here's how I know. If I consider this, well, I denote x squared by t. So I'm going to say let t be x squared. I know that this piece can be replaced by t squared. How come? Because when I square both sides, I get t squared equals x to the 4th. That's how I know that this polynomial can be replaced by t squared minus 257t and plus 256 equals 0. Now, if this power is 3 but not 4, the polynomial is not quadratic in form because this is t, but this is not t squared anymore. But because this was power 2 and this was power 4 and nothing else, there is no other x anywhere, just power 2 and power 4, I'll say, I can replace this by a quadratic equation, making these notations. This I can easily factor. The product is 256 and the sum is negative 257. So I have t minus 1 and t minus 256. Therefore, I have t equals 1 and t equals 256. You can say, who cares about your t? The equation is in x. True. Nobody cares about t. It was a tool to help me solve. But now I have to go back. What is t? T is x squared. What is t? T is x squared. Now I take the square root from both sides. I take the square root from both sides. And I will get guaranteed 4 solutions. 2 from this equation, x equals plus or minus 1. And 2 from this equation, let me write it on the next page. So from x squared equals 1, I get x equals plus or minus 1. And from x squared equals 256, I get x equals plus or minus, is it 16? Anyone can check? The square root. That's it. So I got my 4 solutions. Please read the fine print because they may want you to put comma, negative 1, comma, negative positive 1, comma, negative 16, comma, 16, something like that. Be careful. So I got my 4 solutions. But I had to notice that it's quadratic in form. What if I don't notice? Well, it would be a little bit more difficult to factor. How will I factor if I don't notice? Or I don't know that it's quadratic in form, or nobody told me that, right? So then I have x to the 4th minus 257 x squared plus 256. But it will be more difficult to write this from the beginning. You could, but it will be slightly more difficult. And you will get the same solutions. So this is exactly the same idea because it says, let u be. I use t. You can use u, you can use y, you can use a, you can use any letter except x, of course. So here they will say the same thing, let u be x squared, then rewrite the equation in terms of u, and I have u squared minus 17u plus 39. And that's it. The same thing. So I'm going to just browse through and let me know if we haven't talked about rational exponents yet. And we haven't talked about the absolute value. The absolute value is very easy. So let's talk about the absolute value. I wanted to work on another example from polynomials though. So what if I have this? Let's say x to the 3rd minus 4x squared plus x minus 4. What is the degree of this polynomial?
Third.
Yes. How many solutions are we looking for?
Right.
Of course. It's a polynomial, it's in descending order, no negative leading coefficient, So, what comes out from the first two terms? Please?
X squared.
Good. What is left in parentheses?
X minus 4.
What do I have to have coming out from the other two before I even look?
Has to be the same. X minus
Absolutely. If it's not the same, then I'm in trouble. I can't factor. Good. I need sign and factor.
plus
Sign.
1.
Yes. Plus. Good. What comes out from these two terms? From this term and from
X minus 4.
x minus 4. What is left in parentheses?
X squared plus 1.
Excellent. From here.
Is that the same thing as grouping? I'm just
Of
asking.
course. Of course. But
Okay.
for polynomials, remember this is the only option. So when we factored polynomials, that was our only option, grouping. From here, what do we get?
4.
Perfect. From here, what do we get? When you write x squared plus 1 equals 0, what do we get?
Plus a negative 1. I mean, plus a negative 1. Sorry. Oh, damn.
Right?
That's right.
You're correct. I skipped because we did this before, but you are correct. It's x squared equals negative 1. That changes into that. You're correct. So that was polynomial. I want to look at some absolute value. Much easier than inequalities. Okay, so let's look at this one. So I'm on page 6, absolute value. Equations. So the absolute value of 2x minus 3 equals 9. So here's a question for you. Not good enough. Okay. So I have the absolute value of a number equals 9. What can this number be? What do you think? So that its absolute value is 9. What is one option?
Negative 9?
Yes, it can be negative 9. The absolute value of negative 9 is 9. What else can it be?
Squared?
True, but all I meant was 9. So the answer inside can be either positive or negative 9 because the absolute value will always be 9. That's all the equation. That's all you need to do. You just have to take this quantity and set it equal to 9 and then solve the equation by setting it equal to negative 9. So this inside can be either negative 9 or 9 because the absolute value of 9 will be 9. The absolute value of negative 9 will be also 9. So I have two equations to solve. 2x equals 12. That's the first one. So x equals 6. And the other one is 2x equals negative 6. So x equals negative 3. So the equation has two solutions. You don't need to check them, but let's check them. So 6. 2 times 6 is 12. 12 minus 9 is 9. The absolute value of 9 is 9. Negative 3. 2 times negative 3 is negative 6. Negative 6 minus 3 is negative 9. The absolute value of negative 9 is 9. These are the simplest possible equations. Let's choose another. You choose. 7. What would you do first here? The first step you have to do before you think about the absolute value.
Minus 7.
Not minus, because it's multiplied.
Oh, divided.
Divide. Yes. So let me know if we want to work on 7. Let me know if we want to work on 8. You choose. Or 6. 6 we just, it's the same with what we just did. 7. Oh, it gave me a different 7. Okay, perfect. It gave me a different one now. That's fine. So 3 times the absolute value of 2x minus 7 equals 3. Perfect. So can anyone again tell us of the first step?
Divide by 3.
Yes, I have no choice but divide by 3 first. So I have the absolute value of 2x minus 7 equals 1. I divided the left-hand side by 3, and I divided by right-hand side by 3. And now you're going to tell me two options. What are the two options that you will look at?
Would it be 1 or negative 1?
Yes, but you have to say 2x minus 7 equals 1 or 2x minus 7 equals negative 1. Perfect. Yes. I will move negative 7 to the other side. I get 2x equals 8, and I divide and I get 4. I move 7 to the other side. I get 2x equals 6 and x equals 3. And I box them in, or I write solutions in the form of a set notation, 3, 4. This is fine. This is fine. You choose. Are we okay with the absolute value? These are really the easiest equations.
Yes.
Okay. You want us to